In this tutorial, we will be talking about false positives and false negatives. As you remember, where we were using the logistic regression function to observe where 4 random values of the independent variable will end up in terms of y hat. So in terms of the predicted value for the dependent variable. And we agreed that anything below the 50% line will be projected downwards onto the 0 horizontal line, and anything above the 50% line will be projected upwards onto the 100% horizontal line. And that allowed us to turn probabilities into actual predictions. So either yes or no. Now let's take a step back. Where did we get these 4 values from? So we took 4 random values of the independent variable, and we just had a look at what would happen to them, how we would use the logistic regression function to ascertain what probability they have and what y hat values they have. So how about we take another step back and we forget about these 4 random values, and instead of taking 4 random values of the independent variable, how about we take 4 known values? In fact, let's take 4 values for the independent variable from our data set. So let's just pick out 4 values that we already know they exist in our data set, and we use them to create this logistic regression. And let's do the same thing with them. Let's see where they will end up if we apply the model to them. And as you can see here, the label of the vertical axis changed to y, because this is we already know that in red is the actual value of the dependent variable, because we know the result. Those the people on the bottom, so observations number 1 and number 3, they didn't take up the offer, the email offer, and the observations on the top, people number 2 and 4, they did take up the email offer. So let's see what happens to them if we apply our logistic regression model. So step number 1 would be to project these values onto the curve. Makes sense, right? So we just want to see where they'll end up on the curve. That's our blue dots over there. That's where they have been modeled by the curve. Now, from here we can say what the probabilities are. You just have to project to the left, and you can see approximately that for observation number 1, it's about maybe 20%, 10, 15%, maybe let's say 15%. Observation number 2, it's about 40%. Observation number 3, I would say about 70%. Observation number 4, about 85%. But we're not interested in probabilities per se right now. What we want to get to is the actual y hat. We want to see what the predicted value will be. So we want to see if the model will tell us, are these people going to take up the offer or not? And why do we want to do this is because we already know the result, right? We already know what the result will be or was. And we just want to see, we want to kind of assess the model. We want to see how well it's working and if it's going to make any mistakes. So let's go ahead and proceed with our logic for getting the y hat. And what was our logic there? Well, the same thing that we discussed just a few minutes ago at the start of this tutorial. We're using this arbitrary horizontal line, 50%. So anything below this line is going to be projected onto the horizontal line, which is 0. So where we're saying that the offer is not going to be taken up. And anything above the 50% line will be projected onto the horizontal line, which is 1 or 100%, where we're saying that those people that end up on that line are definitely going to take up the offer. So let's go ahead and do that. There we go. In gray, we have our projections or our predicted values. So y hat is in gray. And it's very interesting to see both y and y hat on one chart. So that means what actually happened is in red and what we predicted was going to happen is in gray. And right away, you can see that for observations number 1 and number 4, so for those people in observations number 1, number 4, we predicted correctly. So we said for person number 1, we predicted that he won't take up the offer, and he actually did not take up the offer because the red mark is also on the same horizontal line. Now for observation number 4, same thing. We predicted that that person will take up the offer, and they did take up the offer. That's good. But now let's have a look at observation number 2 and number 3. You can see that for observation number 2, the gray lines at the bottom, the gray marks at the bottom, meaning that the model is predicting for this person based on their gender, based on their age. Well, in this case, just age, because we're doing a single variable logistic regression. So based on their age, this model is saying that this person is not going to take up the offer because the gray mark is at the bottom. However, we can see that the red mark is at the top, meaning that this person did take up the offer. And that means that the logistic regression made an error here. And same thing for person number 3. The gray mark is at the top, and that means that the model is predicting that the person will take up the offer, but the red mark is at the bottom, meaning that the person didn't actually take up the offer, and therefore the logistic regression made a mistake once again. And these mistakes, they actually have specific names. So the top mistake over there is a false positive or a type 1 error. What does false positive mean? Well, it means that we predicted a positive outcome, but it was false. So we predicted an effect that did not occur. And the other mistake you see here has a different name. It's called a false negative. So we predicted that there won't be an effect, but the effect actually did occur. So our prediction was negative, meaning there won't be an effect, but it was a false negative. And it's called a type 2 type of error. And the way I personally remember them, it's important also to distinguish between the two. The way I personally remember them is I think of type 1 as less dangerous than type 2. So type 1 is less for me in my mind, although it's not necessarily the case, but that's the way I remember them, that type 1 is kind of like a warning. So that's why there's an orange exclamation mark, and it's a false positive. So basically you said something is going to happen, but it didn't happen. So you said maybe there'll be an earthquake, but there wasn't an earthquake. So, that's not the end of the world. But false negative is a bit worse in my, once again, understanding, because if you say something is not going to happen, but it actually does happen, then you can't even be prepared for it. And that's why type 2 is a false negative, and that's how I remember them personally. But once again, it could be absolutely, they can both be pretty serious errors, especially when you are dealing with like medical conclusions and stuff like that. So those are false positives and false negatives. We will be using them more when we talk about the confusion matrix in the next tutorial. And I look forward to seeing you next time. Until then, happy analyzing.